Hi, in this tutorial, we're going to be going over complex rational expressions. So in this tutorial, you'll learn how to simplify complex rational expressions by dividing, how to simplify complex rational expressions by multiplying by the LCD, or least common denominator. So complex rational expressions are also called complex fractions and have numerators or denominators containing one or more rational expressions. So here's an example of a complex rational expression. In the numerator, we have 1 plus 1 over x, and in the denominator, we have 1 minus 1 over x. So here's how to simplify a rational expression by dividing. So if necessary, you're going to add or subtract to get a single rational expression in the numerator. And then if necessary, you're going to add or subtract to get a single rational expression in the denominator. Then you're going to perform the division indicated by the main fraction bar, which is inverting the denominator of the complex rational expression and multiply. And then if possible, simplify. So let's do an example. Let's simplify by dividing. Here we have 1 over x plus 5 over 1 over x minus 1 over 3. So the first thing we want to do is get the numerator and the denominator to have the same denominator. So 1 over x plus 5, in order to get a denominator over x, we got to multiply 5 by x over x. And then to get the denominator, to get 3x, we have to multiply the numerator by 3 over 3. And here we're going to multiply x over x. So now we get 1x plus 5x over x over 3 over 3x minus x over 3x. Now we can combine the numerators, so we get 5x plus 1 over x divided by 3 minus x over 3x. Well, now this is means division, so now we're going to take our reciprocal and then multiply. So now we're going to get 5x plus 1 over x times 3x over 3 minus x. So we just took the reciprocal of this. So now all we're going to do is multiply across so that we get 5x plus 1 times 3x over x times 3 minus x. So now we get 3x plus 15x squared over 3x minus x squared. So now we can factor out an x so that we get 3. We can factor out a 3x in the numerator so that we get 1 minus 5x over x minus x times 3 minus x. So now we can cancel out these like terms, which then gives us 3 minus 15x over 3 minus x. So that's our answer. Now here's how to simplify a complex rational expression by multiplying by the LCD. First, you're going to find the LCD of the rational expression within the complex rational expression. Then you're going to multiply both the numerator and the denominator of the complex rational expression by this LCD. Then you're going to use the distributive property and multiply each term in the numerator and the denominator by this LCD, and then simplify each term so that no fractional expressions should remain. And then lastly, you're going to simplify the resulting rational expression if possible. So let's do an example. Again, let's take 1 over x plus 5 divided by 1 over x minus 1 over 3. So to find the least common denominator, we're going to find the least common denominator of our lowest denominator. So here, our lowest common denominator, to combine these, would be 1 over x times 3 minus 1 over 3 times x. So now we get 3 over 3x minus x divided by 3x. So our least common denominator is 3x. So now what we're going to do is to multiply the numerator and denominator by the least common denominator. So now we're going to multiply 3x into 1x plus 5 and 3x into 1 over x minus 1 over 3. So this gives us 3x over x and 15x plus 15x. And in the denominator, we get 3x over x minus 3x over 3. Okay, so now we're going to multiply this. Now we can cross cancel our like terms. So now we get 3 plus 15x divided by 3, we cross that out, minus x. So that's our answer. So in this tutorial, you learned how to simplify complex rational expressions by dividing, and how to simplify complex rational expressions by multiplying by the least common denominator. So now try and solve problems in our complex rational expressions workbook. For more help, sign up for online tutoring. And in the next tutorial, we're going to be going over solving rational expressions. Thank you.